This is a really nice torques question. So there's a beam which is sitting out here, and there's a rope holding it. This is the wall here. And there's a mass hanging off it. The beam has a mass of 20 kgs. So we've got that 100 kgs, which is 1,000 newtons acting. We've also got 20 kgs, so 200 newtons. And that acts in the middle of this beam. It's 1.2 meters, so at 0.6 meters for another 200 newtons acting down. Alright, which of the following gives the magnitude of the torque on the beam about point Q? That means the centre of rotation is Q. About point P. Centre of rotation is P. This is our. That's what they mean by about the point P. Due to the weight of the 100 kg mass. They want to know only the torque from this guy here. So torque equals force times radius. Force is 1,000 newtons, and it's 1.2 meters to the centre of rotation. It's 1,200 newton meters. Which of the following gives the sum of all the torques acting on the beam about the point P? Well, is the beam stationary about the point P, or is it rotating? It's stationary. There's some things pulling it down, but there's also this guy pulling it up. So the sum of all the torques around P is 0. They all cancel out. It's a bit of a trick question, that one. And the last one, which gives the tension in the cable RQ? Which gives this force here? Force of RQ. Alright, now we've got to use all of these torques and set up one of these torque equations and say the torque clockwise is equal to the torque the anti-clockwise, because they all cancel out. Here we've got the clockwise are the ones trying to rotate it around this way, which is this guy and this guy, and the anti-clockwise are the ones trying to pull it back up this way, and that's this guy. These are very anti-clockwise. So we've got two torques over here, F times R plus F times R, and that equals the anti-clockwise torque, FR, but it's on an angle 30 degrees. Sine theta. So the first one clockwise is 1,000 and it's 1.2 meters, which is one we've already calculated before, plus the other one is 200 newtons and it's 0.6 meters. And that equals the force of RQ, which we don't know. The distance to RQ, from here to RQ, is 0.8, times sine, the angle is 30 degrees. Alright, let's do those. So that's 1,200 plus 200 times 0.6 is 120 equals F RQ times 0.8. Anyone in my class will be able to work out sine 30 in the head. Sine 30 is 0.5. So we get 1320 equals F RQ. 0.8 times 0.5 is 0.4. Rearrange that, you get F RQ equals 3,300 newtons.